And I looked it up. Oh, wow.
What's up, guys? Thanks for coming and thanks for tuning in. We're here at the Sema show 2020 or 2019 Sema show at the Toyota booth, and today we're going to build the B58 engine live. Thanks for tuning in. If you have comments or questions, go ahead and put them into the YouTube interface there, and then we'll stop at some point and answer some of those questions. Today we're going to try to get through all of the rotating assembly, the short block, so cranks, rods, pistons, and maybe the head studs. We're going to be here 2 more days, so today's Wednesday, Thursday, tomorrow we're going to work on the cylinder head, the cams, valve train, and get all of that assembled, and then Friday will be the turbocharger, manifold, intake manifold, and all the other accessories that bolt to the engine. So let's get started. So we shipped everything, actually the engine was at our shop. This is the same one that we assembled on the other videos. And we were on the dyno for a couple of days. We've pulled it apart, cleaned all of the parts, and shipped them all individually here to the Sema show in Vegas. And now we're gonna reassemble the engine. The first thing I'm gonna do is put in all of the main bearings. So the main bearings are what goes in between the crankshaft and the block. So I've already spent a little bit of time today kind of laying everything out and trying to clean everything as good as I can. It's actually really low dust in the convention center here, which is good. Everything is numbered from 1 to 7. So I gotta make sure I do this right. 1 is always the pulley side, which is the front of the engine. And I made little Sharpie marks so I don't make any mistakes. So I'm starting from 7, and I'll count my way down from left to right. So I have not pulled out the piston squirters, but if you look inside here, you'll see these like little tubes that would be up in the block. The block is actually upside down right now, but these squirt oil onto the bottom of the piston to help cool them and also help lubricate the rings and the cylinder walls. All the bearings are the same except for the center bearing. It has these what they call thrust washers on it, and they're actually on this engine they're connected. They don't come off. And the main bearings are the bearings for the crankshaft as it spins. The thrust bearings are in the thrust direction. So like if you push on the clutch or whatever, they push up against this bearing. And they've got a little bit of light engine oil on them right now. And then I'll put some engine assembly lube on them before we put the crankshaft in. And then so, you can build these a couple of different ways. If the engine's going to be started right away, and I feel like you already know the engine's tuned well and you're not going to be cranking it a bunch, you could probably assemble one of these engines with just engine oil. But if it's going to sit for a while, I like to use an engine assembly lube. So I've got this Lucas stuff that's pretty thick, and it's got a plastic applicator, so I could touch the bearings and it doesn't scratch anything. And you can see it's like super thick, so it stays where it's supposed to stay, where you want it. And you can see how it's like super tacky. So just spread that on, pretty easy going. On the thrust bearings too. So I'm always wearing gloves just because I feel like it cleans, my hands clean up better. It's easier to clean the oils off the gloves than my fingers. And I'm less likely to slip and drop something, like the crank. Okay, so I'm gonna bring the crank in. I'm gonna, I don't know, maybe walk around this way with it. So let me double check. So I've got all the bearings in. The oil squirters are in. I've already wiped down the crank. Yeah, so. So I'm gonna plan my attack on this. So I know this is the front, so I'm going to hold it in a way that I can just set this right in. And these things are like 30 pounds, so got to make sure that your slippery hands don't drop it. Cool. Then I'll kind of rotate a little bit and just make sure everything feels normal and feel that the thrust is right. So all the bearing clearances and the thrust and all that stuff's already been pre-measured at the shop. So today we can just get through an assembly and not have to deal with all of the clearances and stuff. Okay, so same thing. I'm going to work from left to right, but it's 7 through 1 main cap. So let me pull out all the bolts. And then these are, I always use these pink rags because they're lint free. So the thing with like shop rags and stuff, like we have rags like these white rags or whatever, but they leave lint. And if you get some of that lint like between the bearing and the cap, it can actually space the bearing up slightly and change your clearances. So you want to make sure that you don't, have anything in between any of the surfaces. That's why these rags are good. So again, just a little bit of lube. And then they only go on one way, which and a lot of engines use dowel pins to align all these, but this engine, it has like these teeth, and the teeth sit proud of the mating surface, and then the initial assembly, those teeth dig into the block, and that's what locates it.
Good afternoon, everyone.
I haven't talked to any engineers about why they do that. I don't know if it's to save components or whatever, but it's worked well. And again, on the number 4 main, you can see the same thing where it's got the bearing and then it's got the thrust washers built in. So I'll lube that, all the bearings. And then on the main caps, if you see that there's these other bolt holes, later in a little bit, once we have all the rods and pistons in, there's a big girdle that ties in all the main caps to the skirts. And I'm always paranoid, so I'm always like double checking everything I'm doing because the stuff's so deep. Like, you can imagine if you put one of these together and then it's all the way in the car, you can't just fix it. I want to be able to like remember back, like, did I put all the main caps on right? Like, yeah, I remember looking at all of the numbers and then they're in the right place. Or I remember torquing everything. I remember double checking all of the torques. I got video proof of it. Or if I make a mistake, then we look back. So these bolts, these are actually the factory bolts. They're torqued to yield. They've got a little bit of engine oil on them already. So I'm just going to assemble them just like that. So these all have a specific torque, and I've got a whole clipboard written down with all the torques of the engine because I don't remember them all. And then in a minute, we'll go ahead and torque them. So these are the stock main caps. Typically on like really high horsepower stuff, you'll replace these caps with like a billet machined one instead of the cast. So in the future, that's something we're looking to upgrade, is the main caps to a billet style one, and then the the bolts to a stud style. But in this first version of this build, we're not running those yet. And then what I'll do is turn them in a little bit just to make sure that the threads are engaged. And then I can use the impact to run them in to save time. And these all use a Torx head, like a Torx socket. So it's not a normal hex. Which at first I was like, I don't know. But then after I use them, it's whatever. It's just another bolt. So I'm just tightening them down to just basically so it touches. I don't want to get too much torque on it.
So what did you use to get the torque specs for that?
The factory service manual has all the stuff. Yep. So then I'll just make sure that there's nothing weird binding it up. Okay, and then the torque on this one. So I've got my little clipboard here. So the main caps, engine oil and threads, and under the head. Step 1 is 18 foot-pounds, and then 65 degrees, and then 65 degrees. So that's what we're gonna do. Okay, so this thing's digital, so I'll program the 18. That's what I said, right? 18, 65, 65. So it's 18, and then you can switch to angle, so it needs to reset. So this angle torque wrench, it does angle at any angle, like, so 65. All right. So first step is 18 foot-pounds. Let me get all the sockets set up. And we'll start in the middle. I kind of go in the middle and then out. I like to rotate a little bit each time to just make sure that nothing I did caused something to bind or whatever. Because I've had engines in the past where I'll assemble it and like it didn't turn, but I didn't know which part of the engine or what I did maybe wrong caused it. So I like at each phase to sort of make sure that we're all good. Okay, and then to double check, I'll just go in like a kind of sequential here so I don't skip anything and just make sure I didn't miss anything. That's the whole like double checking part of, I think, engine building. That's really important. So you try to take out the human error side of it. All right, so nothing turned, everything's torqued. Okay, so next we're gonna do 65 degrees twice. So normally I would do lat order, but I'm actually just gonna go from left to right and then from left to right. That way I don't do 65 not enough times. And what's cool about this torque wrench actually counts. So I should be, what has it got, 2, 4, 6, so 14, right? So I should have 28 when we're done. Sometimes it's 65, sometimes it's 67. It's not that critical. Okay, so that's one pass. Okay, so one more. And it's interesting, you can kind of feel the bolt like lay over a little bit. Like you get torque, and then it sort of doesn't feel like it's torquing anymore. That's the yield part of the bolt. It takes some getting used to. And you can see the maximum torque, so it's actually torquing up to 75 foot-pounds. Or 74. So once you kind of know that, there may be an option, I guess, to just torque it to that torque, but it's more of a reference that, you know, if one of them only torqued to 60, then you may have yielded the bolt beyond its, but these are all between like 73 and 76 foot-pounds. So they're all giving a similar clamp load. Okay, so that's it. Crank still turns. That's good sign. And let's see if it counted. So it did 55. Maybe I don't know what that number means. Should read the manual. But I'm confident that I did everything right with the torque. So next we can move on to the rods and pistons. All right, so in order to do that, we're gonna flip the engine over. So right now I'm just also checking the thrust. After you build enough engines, you kind of know what, 6 or 8 thousandths feels like. So everything feels fine. All right. So I'll start with cylinder 1, and then we'll kind of go down the line. So there's just a light coat of engine oil on all the cylinders, and the pistons are dry. These are out of the solvent tank at the shop. And the rings have a little bit of engine oil on them. So if you want to come over, I'll show you the pistons and rods. I'm going to work on the table here a little bit. So this is the oil ring expander. So the way the oil ring are the bottom rings, and their job is just to keep the oil down in the crankcase and not up on the rings, the top rings. And this is a little spring that it pushes out the rings. So they have different tension oil, some low tension, high tension oil rings, depending on the build design. Nowadays, even like racing engines would go to a low tension oil ring, but nowadays even factory engines use a really trick ring package where it's like a small width ring and low tension, so it's less drag, because they don't want those parasitic losses, so it's better fuel economy. and they just do a better job of making the cylinders round and honing them correctly and doing all those things to make them seal up well. So this is one of the oil rings. It goes on the spring, and then the second oil ring, so it fits in the groove and actually fits on that spring, and then once it's all assembled, you have a whole oil ring, and it's larger diameter obviously than the piston, and it's in static it's larger diameter than the bore, so when you put it in, it compresses and it has pressure pushing out on the bore. And then I'll align them. So intake is the tang. So the pistons are designed where they have a larger cutout for the intake valves are larger than the exhaust, and so these cutouts in the valve are specific. So they could, you don't want to put them in backwards. They're only going one way. And same thing with the rods. They have a little tang for the bearing. Right here, that aligns the bearing, and that tang goes either towards the intake side or the exhaust side. On this engine, it goes toward the intake side. So we will hold it from the intake side. Actually, I'm going to hold it from the intake side. And then the second ring, these have an up and a down. So I'll install that. Those are always a little scary because you could break or ring or something, and you don't want to do that. Okay, let's put that way. Double check I have it right way up. Done. Okay, so rings on, cylinder 1. And I'll just go down the line here real quick. Take. So these are actually the factory Supra rings, the rings that came in this engine. This is actually a new set though, but the block has a really special plasma sprayed cylinder liner. So it's an aluminum block with a steel liner in it that they plasma spray on, but it's really thin so you can't bore it over. And we liked the technology and we feel like the ring is a really good set, so we just we worked with JE Pistons to design the pistons around the factory rings. So it's actually the factory ring setup. And then these pistons are coated on the skirt and the top. So these are actually been run, but I wanted to get out one new piston so you could see it. So that it has a low friction coating on the skirt and then a temperature barrier on the dome, or this was a dished piston, but those are the two coatings on this piston. So before I knew the first engines I built, I actually just followed the service manual. A lot of especially the older service manuals, the paper ones, they would go really in depth into how to rebuild the engines. And they would talk about, where to line up the rings and bearing clearances and all these different things. Because I was in the 90s before, much internet. So the service manuals are where I first started learning how to build engines. And then after you read a few service manuals and after you talk to friends that build engines or some engine builders, you start asking about the bearing clearances and ring gaps and stuff that they use. And then you start getting an idea of sort of the range in which bearing clearances are always set, or usually set, and where ring gap is, so when the ring is installed inside the block, it will compress down to whatever the the bore is of the block, and there's going to be a certain gap in between the ends of the ring. So typically higher temperature, higher pressure, higher performance engines, you may want to open up that gap a little bit, because as the temperature of the ring rises, it will expand and start closing that gap. So if you have a lot of heat into the ring, and what you don't want it to happen is that ring actually butt together, and that can cause issues. So typically on race engines like this, where you're fine with maybe a little bit of compression loss on like a turbocharged engine, naturally aspirated, they're going to be really specific on that because they care about every horsepower. But for us, we may err a little bit on the larger side, so it's a little bit stronger versus, or a little bit more forgiving than just the peak every little horsepower possible. So again, the oil ring on top of the expander. Can you get this? Yeah. And then the second ring, which has a little markings on it. I don't know how close you can get in with that that camera, but if you look, the ring actually has a small feature on it where it's like an L-shaped kind of cutout. Can you see that? So these are elegantly designed to where there's a top and a bottom. You guys can see that. The bottom ring actually has a little feature on it. So the part that the feature goes down. So if you can see, there's a little cutout in there. So I don't know exactly why they do that, but probably has something to do with oil control, because the second ring has a lot to do with oil control as well, and then the top ring is mostly compression. So these are usually like a cast. These are different material than the top rings. The top rings are a harder material. But it's like the factory stuff nowadays is better than the racing stuff from 10 years ago. At least like our aftermarket, maybe not Formula One or IndyCar level stuff, but like from what we were doing, you know, in the automotive aftermarket here, the factory stuff is so good now. And these pistons also have what they call gas ports. So these are not the factory pistons, these are the JE pistons, but with the factory rings. And we designed them with what they call gas ports. So if you look at the piston, they've got these holes radially drilled. And the combustion or the compression pressure can actually get into that hole, and it goes around to the back side of the compression ring and actually pushes out on the compression ring to help it seal more. See all those holes around the top there? Oh, what's up, dude? Good to see you. The OE doesn't have that, but this is something that that we add on the racing pistons. So if you look at all the radial holes on there.
So they actually go all the way through?
Nope, they just go enough to the back side of the top ring.
I was going to say, that'd be insane. Okay.
The oil holes do.
Oh, they do?
So the oil holes, the way that the oil holes work is, I believe this is right, as the piston rings catch the oil, it allows the oil to, I think, return back into the crankcase. But if you look, those are the oil ring holes on the bottom ringland there. Can you see it? Yep, and those are compression. And again, the tops, this engine has been run. We pulled apart, cleaned it, so you can see some of the wear on the skirt, which is what you want. That's fine, and some of the discoloration on the top. This is what it looked like originally when it went in. You can compare it. So this is run. This is not run. So keep going.
So those return, that would allow the oil pressure to squeeze through in there.
Yeah, as the oil ring comes down on the cylinder, it scrapes the oil off and it returns. I believe through there.
Okay, like a relieves pressure.
Yeah.
Yeah. Makes sense.
Okay, so we're on number 4. Getting there. Maybe in the future I'll have all the rings set up except for one. But it's cool. We got a couple hours here, so. Jen, any questions about this? Okay. And I'll install these differently. Like the bottom ring, the second ring, the middle ring is typically more brittle, so I won't want to twist it. So I'll put both kind of ends in its groove and then use my thumb to open it up. And then it should pop onto that groove. Sometimes I'll get the glove stuck in there and then like a little piece of glove, so I have to watch out and make sure I don't get any glove stuck in between the ring and the piston, because that could cause it to never seal up properly. That's one of the downsides of the glove, is you have to make sure that you don't leave it inside the engine or any parts of it inside the engine. All right, 2 more. So the oil ring expander. So I can, are we good on this one? Are we good on this one? So if you're just joining us right now, we're at the 2019 SEMA show. We're at the Toyota booth, and we're building a 2020 Supra B58 engine live here at the show. I've never done anything like this before, so it's pretty fun sharing the process. Today we're going to do the rotating assembly, the short block, crank, rods, pistons. We're going to be here all week, so tomorrow, Thursday, we're going to do the cylinder head, cams, and all the valve train. And then on Friday, we will do the exhaust, the turbo, and the intake manifold. So right now what I'm working on is getting all the rings on the pistons. The crankshaft is already installed. And then once I get done with this, then we can drop the pistons into the holes and then start torquing up all the rods. Sorry if I'm quiet for a minute. I just want to make sure I get everything right. Okay, and then the last one with the new piston, we are going to install the piston on the rod. So in order to do that, I'm going to work on a towel instead of our tablecloth. So I'm going to I'll get this towel. This one looks fine. Flip it over, and then we'll clear off an area here. Can you see this one okay? Is this enough lighting? Okay. Actually, I'll get a fresh one. It looks better. I got a roll of towels hiding underneath. All right, so move all these down a little bit. And all the rods, and I've numbered everything. So all the rods are numbered. I don't know if you could see, if you could try to see that, where it says 5A. So I've numbered them 1 through 5, and so we know where they go, and the cap matches the rod. You don't want to mix them up because when they hone them, they're all matched. And then I put an A because this is the first engine that we're building. If we do another one, I'll mark it B and C, and and that way they're always matched, not only to the engine, but also the cap to the rod. Okay, so we need to figure out which is the intake and the exhaust on this. And in order to do that, they're so close. This should be the intake, but I'm going to double check that. We're going to use the poor man's caliper, and we're going to get this, and we're going to go to here, we're going to go to here. Yeah, so this is the intake, it's slightly larger. So intake, the intake goes on this side, it's the front. That's the front, it's the intake. And I know that yeah, I'm confident with that. So sometimes if I don't know, like if they're really close, like the both of the valve, the valve pockets, is I'll actually take a valve, like an intake or an exhaust valve, and just set it on there. And then you can really see like the larger one or the smaller one. But you can also be deceived by that because sometimes the intake or the exhaust may be cut a little bit deeper. Just something when you're building an engine, you just really have to pay attention to, that you make sure you put the piston in the right orientation. So I know that that's the intake side. I know that's the front of the engine. So I put an arrow towards the front. And I know that these rods, just from experience, that the bearing tang, which is that part, goes towards the intake side. So I'm going to take my Sharpie, and I'm going to, I know that's the intake, and I know this is the front. So I'm just going to take some Sharpie and put it here, and I know that's the front, and the front lines up with the arrow, and I can make sure that I assemble that properly. So the next step is these two little clips that hold the piston pin in, and this is an upgraded pin. If you look at it, it's like super thick. So the cross section, and it's quite heavy. So when the piston's getting pushed down, or on the exhaust stroke when it's pulling apart. What's up, dude? Good to see you. You can from all the compression, you can actually bend the pin. So we've upgraded to a much more robust pin. The downside is a bit heavier, but we're more worried about it not bending than weight. So I'll put everything out of the way. I'm looking for a flathead screwdriver, and I will install these clips. So the clip goes in this little groove. Can you see the groove? And that's what stops the pin from sliding out either way. It's just a clip on either side. So that's how you install the rod on the piston, is you just put a pin through it, and then these clips hold it. So I'm going to put one side in first, and these are always a little tricky because there's a lot of spring pressure, and they can fly out. So if you guys see one fly, find it for me, because I only brought two. I only bought enough for what the engine needs. All right, so I got one in, and if you look, it's now in the groove. And then the pin cannot go past it. And the pin actually has a little bit of a chamfer on it, or a bevel. And what happens is, if the pin tries to push out, it'll actually, that little bevel will push the little retaining ring even deeper into the groove. So that's almost everybody switched to this type of retaining system because it's just super secure. So that's the groove or the clip, and then if you look at the bevel,
That's cool. Okay.
yeah,
Just pushes
it's really simple. Yeah, and it's inexpensive and reliable. So that holds that in. So I will get some assembly lube and put that on all the parts. So this is a forged Carrillo connecting rod that they built specifically for this engine. It's called an H-beam. So the cross section looks like an H. So it's very fat and it's quite thick, but they remove material where it's not needed to try to keep the weight down. And it uses a bronze bushing. So that's what the pin rotates on. And the way it gets oiled is it's got these two little holes on the top, and the piston squirter will squirt the bottom of the piston, and then the oil will actually fall down into these holes and then get into the pin, and that's what oils the pin. Get enough oil on the pin. I'll put a little bit of assembly lube into the piston. Yeah. So we'll assemble this before I put the rings on it. And then we'll put the piston pin in. I'm gonna make sure, okay, so that's the front of the engine. That's the intake side. That is the tang, which goes on the intake. And then I mark the front of the engine there. And then it just gets installed like that. Then I'll triple check it that that's right. And then put the clip in.
Steph, do you have a sec? Let's ask some questions.
Yep, let me get this clip in and then I'll answer questions. So these they kick my ass sometimes. They kick my butt sometimes. Typically what works best is I'll get both of the corners in and then try to push at the top here. This one's not cooperating. So I don't want to use tools too much on it because I don't want to, oh, there we go. So I've got it past there, and then I'll use the screwdriver to, okay. So I only want to use the tool in a way that if I slip with the tool, it doesn't damage something. So I don't want to use the tool to try to get the clip in the main bore initially, because if I slip, I might hit one of the ring lands. So that's why I'm using my thumb on all that. And then once I kind of get it deeper, then I'll use the tool to push it the rest of the way in. So that's all the way seated. It's all lubed up. I'm gonna check again that I put the piston on right. So that's the front of the engine, that's the intake. I've marked here, and that's the,
So how
yeah.
many times you check it?
Probably 4. Like, it's that crazy. So I used to work for an engine builder back in the 90s, and he had some engines come back where one of the guys put it in backwards, and I was like, that's never going to be me, never. And if you put it in backwards, it's catastrophic because the valve cutouts, the reliefs, are specific for the valve, and if this goes in backwards, you can have valve to piston contact, and the engine's coming back apart. So, and I have a pretty poor short-term memory, so I have to have like systems to not forget. Yeah. Okay, so questions.
Couple questions. Keep the question. Screwdriver has a difficult one for you. How much power can the stock exhaust ports flow?
So how much power does the stock B58 2020 Supra exhaust ports flow? That's what we're gonna, maybe, I don't know if we're gonna find out the limit there, but the plan is to try to get to 1,000 with those stock exhaust ports. Slightly ported out. I don't think we improved the flow more than probably 15 or 20%. There are guys already making, I think, 600 or 700 horsepower with bone stock engines. I'm confident that you can make 1,000, but how much boost do you need to get there, right? So ideally, you don't need a whole bunch of boost to make the power that you need, because the higher the boost, the intake air temps go way up. It's more likely to knock. It's harder on the whole system, and it's just not ideal. So we'll see. Stay tuned. That's something we'll address in this in the fourth video where we talk about on the dyno and the power we can make.
And then Jeffrey H.
Jeffrey H. Yeah.
Are the pistons always put back in the same cylinders?
Do the pistons always go back in the same cylinders? If we're rebuilding an engine, yeah, we always want to put all of the same parts back in the same engine. We always want to put the same parts back in the same location. So rings, pistons, bearings, even the valve train stuff. So if we're pulling apart a cylinder head, all the valves and all the retainers and everything go back in the same area, because what will happen is they may have a little microscopic wear where they sort of married each other, for lack of a better term, and so you kind of keep that going. And then later on, if you have a problem where you see an excessive wear, it's due to those two parts touching each other, not a third part or some other mating situation that it doesn't exist anymore. So you want to try to keep just some consistency. That way, if you ever look back, you know the history of it. Yeah.
The Renshu asks, how reliable do you think this engine will be?
So the question is, how reliable will the engine be? That's a good question. Yeah. So by the looks of it, it looks pretty reliable, especially even at the power that we want to make of 1,000 horsepower. You know, it's one of those things where the harder you push an engine, typically the less reliable it will be, right? So at 335 horsepower, which is stock, it should go hundreds of thousands of miles because they've already tested it there from the factory. If you want to make 600, probably less. You know, it's just intuitively you'd think less. If we want to make 1,000, for us, if we're building an engine for like a drift competition, we want it to go 4 events, so half of a season. If we can get it to go 4 events, then we think it's a successful build. We don't want it to fail at that 4th event. We want to be able to pull it apart, rebuild it, or see what needs to be rebuilt, put it back together, and put it out back into service. And that would be considered a reliable engine at 1,000 horsepower.
What brand of shop towels do you use?
So, it's a good question. These are, we will post, are they, you know what, let me look. I'll find out exactly. On my, I gotta look, and we'll post it on the description down below. I think it's, I don't remember. I get them on Amazon though.
Shop
Yeah,
towels?
yeah.
And then a few people, Theo, wanted to know what type of piston are you using?
Yep. So this is a forged and machined JE piston, and it was specifically designed for this B58 project. And I think if you call them up, you can buy exactly the same stuff that we're using here. It's not anything that we ever plan on selling. It's just something that we worked with JE on to design, and they were nice enough to have some of their engineering team work with us on the project, and that's the value that we get from it, and then they get a piston that they can sell in the future. All right, so now we've got, so good questions. Thanks, everybody. Keep them coming. So now that we've got the piston on the rod, we're going to now put the bearing back in. I'll make sure that it's all clean between the bearing and the housing. I'll line up the bearing tang. And these bearings are coated from the factory. So this is a factory bearing, and it has this red coating on it on the top bearing. And the rod side is actually not coated. These have already been run, actually on the dyno. And the oiling system and the bearings are so good that they don't even look like they've been run. So we're reusing them. And yeah, man, the factory stuff's pretty good. And if you look at the rod, so there's these little, what they call dowel pins or roll pins, and they line up with these holes. And that's what aligns the rod perfectly with the cap. So I'll show you guys. So sometimes they use a dowel pin outside the bolt. These ones use a little roll pin, on the cap. So it's just go into that hole. And so you can't put them on backwards, and they align them perfect.
These motors are geared for.
All right, so almost there. One more set of rings. Oh, hey, what's up? Good to see you. Yeah. Yeah, it's all good. Yeah, hey. Okay, for sure. All right, one last set and we'll move on to actually some other part of the build, which is putting the piston into the cylinder. All right, start with the oil ring expander, then the oil rings. Sure you guys got enough of this. If you're just joining us on the YouTube Live, we are building a B58 2020 Supra engine live here at the 2019 Sema show in the Toyota booth. We're doing it all Wednesday, today, Thursday and Friday, all week. Today we're doing the rotating assembly, which is the piston, crank rods and pistons. And then tomorrow, Thursday, we're going to do the cylinder head, all the valve train, and then Friday will be the turbo intake manifold and all the accessories that bolt to the outside of the engine. And I'm trying to do this in a way that I guess is sort of engaging without feeling like a infomercial. Because I hope, my goal here is to, maybe get some people inspired to build some racing engines or your own project, or if you want to learn how to build engines, maybe you take apart a freaking lawnmower engine. I mean, four-stroke, four-cycle engines work very similarly. They all have pretty much the same components. So you can start on something like a scooter, and that's low consequence, and then eventually kind of work your way up to bigger engines if you want. The stuff you learn from the small engines or simple stuff, or even something you find in the junkyard, applies.
That's how you get started.
That's how you get started. That's right.
And if it's for you, you'll know, because you won't be able to stop.
So, okay, so we got all the rings on. So now what I'm going to do is prep everything for installation, so I just have to do it once. So I'm going to start and just put assembly lube on all the bearings, which we can knock out. And then I'm going to put assembly lube on all of the rod bolts, and then we can drop them in. And again, I got all these lined up from cylinders 1 through 6. And again, I'll double check each time, triple check everything. But I can't stress that enough, how focused you need to be. And because we're doing this live and I've got people watching, I want to make sure that I don't forget anything, because it's a little bit out of my normal routine. So if I seem a little redundant here, that's why. I just want to make sure that I haven't overlooked anything. Okay, so we've now put assembly lube on all of the the rod bearings. And I'm gonna now I want to match everything up. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, and 6, and then, excuse me, all right, and then the rod bolts take a very special lube because these are relatively small bolts for how high we torque it. So Carrillo has a special assembly lube, and you want to stick with whatever the assembly lube that they recommend, because if there's a specific torque, that torque on a rod bolt, when you torque this, it's going to eventually seat, right? And then as you continue to torque, it's actually stretching the bolt a little bit. And there's tools that we can use that you'll zero out when it's not torqued yet, and then you torque it, and then each bolt will have a specific amount of stretch that it needs, and that stretch will give a lot of clamping force. If you stretch it too far, you can actually yield the bolt and it won't return, and you'll have ruined the bolt unless it was designed for it, like a torque to yield, and you can have potentially a failure. If it's not torqued enough and there's not enough stretch, the bolt can actually come loose. So what keeps these bolts from not falling out is not any kind of Loctite or anything like that. It's actually the elastic stretch and its continued force resisting it being unscrewed. So this is a special lube that Carrillo specs out. So I've already assembled these at the shop and tested the rod stretch, so I know with these bolts what it is that they need to be torqued to. Depending on the engine builder, they may check the stretch on every bolt every time. I don't, but there's different engine builders have different philosophies and different ways of building them. So now I'm going to make a bit of a mess, so you can see. So what I want to do is get the rod bolt assembly lube on all the threads. So I'm just going to liberally apply it to the thread, and then the little leftover I'll sort of scoop under the head, because those are the two areas that make contact with the metal, and that's a lubed up bolt. So again, get it all up in all the threads, and then under the head. All right, keep going. So on a lot of stock cars, especially older ones from the 90s and stuff, sometimes they can have rods that can handle, extra power. But they may not have rod bolts that can handle the extra RPM. So there's different companies make replacement just rod bolts. So the rod bolt not only helps keep the cap obviously all connected, but at high RPM, when the piston goes over top dead center, you have all that mass trying to basically stretch the rod apart. So it's not only trying to stretch the rod apart, it's actually trying to pull the rod bolt. And what can happen is, if the rod bolts aren't up to the task, it can actually yield the bolt, and it can come loose due to that, and then because it can have a catastrophic failure because now the rod cap is not held on properly anymore. So there's stories of guys, pulling engines apart and the rod bolts are not tight anymore, and it's not necessarily because the assembler didn't tighten them properly, but the bolt could have yielded during service, and then it didn't hold its clamp anymore, and it actually just worked its way loose because it stretched and didn't return to the normal length. And I'm getting a little sloppy here, but I always err on the side of a little bit too much assembly lube than not enough. And I actually have new tablecloths for each day, so I can make a little bit of a mess and start fresh each day. All right, so now we've got everything all lubed up, and I'll put this bottle away because this is only for the rod bolts. And I made a mess, so I will change gloves. And I'm gonna take a break for like 30 seconds and get a water. Let's see. Are there any questions here? Yeah.
What compression ratio are you running for Cillian?
This is 11 to 1. I think the factory is 10.5 or 11. I think it's relatively high. With the new direct injection setups that most of the engines run, they're less susceptible to knock because of the way that they inject the fuel. And you've seen like a lot of factory engines, a lot higher compressions that they've been in the past. Yeah.
This is going to be high boost though, and you're like full pump, right? Still maintaining 11 to 1.
Yep. So we're keeping 11 to 1. We're running an Ignite E85 ethanol-based fuel, and it has a high knock resistance. So the trend has been with turbocharged engines to go with higher compression. You know, even from our drag racing years back in the mid 2000s, 2005, 2007. We were going with higher compression, and the race engines are good. You just have to keep an eye on the tune, but they're not good if you're trying to run like California 91 octane and things like that. So that's the limitation of the compression. But on a race engine like this, we're fine with it.
And is it Ignite E85 or do you run E98?
The ratio,
Yeah,
or the
it's like Ignite Red or Ignite Yellow?
Ignite Red, which I think is like an E90. No, it's not the E98 one. It's the red, which is the 114, I think they call it. But it's Ignite Red.
And
Yeah.
you said 2000cc injectors?
2000cc injectors, yeah. So I'm trying to, sometimes the gloves don't go back on because my hands are sort of sticky. All right, so here's the trick. Try to get these back on with, oh, good. All right. All right, so we're gonna assemble, let's see, we've got pistons on the rods, rings on the pistons, oil on all of the bearings, lube on all of the bolts. So we're gonna start with cylinder 1, which is the front of the engine, which is where the crank pulley goes. And I've lined it up from left to right, and the engine's from left to right. To compress the rings, we're going to use a tapered ring compressing tool, which I've got here somewhere. So this is an 82 millimeter bore. This is just something that ARP makes. It's just a tapered aluminum and anodized deal where it's actually, you know, tapered inside. So I'm going to make sure that this is clean, and it's still a little oily from the last time I did an engine. So, but you don't want this dry. You want everything with a little bit of oil on it so it slides nice. I've already cleaned all the bores and left a little bit of oil on them, so that's fine. Okay, so I'm going to take the piston and rod, make sure that my rings are aligned where I want them. I'm going to hold it with the intake side, which is this way. So I'm actually going to mark them all. Again, this is like redundant steps to make sure everything gets installed properly. So I know this is the intake side. I know that the tang on the rod goes to the intake side. So I'm going to hold it that way and then put an arrow towards the front of the engine. And marker number 1. And then same thing on each one of them. That's the intake side, that's the arrow, that's the number 2. Hold it from the tang side, arrow, 3. Hold it from the tang side, arrow to the front, 4. 5.
Pins are on the rods except the 401. It's on the cap. Did it just...
It came off that way. Yep. And this is 6. All right. So now I can just go with it. All right. So number 1, front of the engine, align all the rings. So the gaps, I usually set the top and the second 180 apart, and I like to have the oil rings kind of on the other side of the second ring. You don't want the gaps on the pin axis or the in line, but the main thing is don't have them on the pin axis. So kind of diagonal. I don't know. Every service manual I've read, there's never on that. The same thing, I think, if you read like the literature on different rings and the JE stuff, you don't do it on that one. Okay, and so then we're gonna put it right through our tapered ring compressor. And so how it fits in easy on the top, and then it starts compressing it. I'm gonna take the crank and move. Oh yeah, I need to put the pulley on. I always forget that. Let me find the crank pulley. Crank pulley's here. This one is top dead center. Sorry, it can go on 4 ways, but it's not keyed, so. Put the number 1 to top dead center. I know that my marker is somewhere over here. And this engine uses a flange type pulley, which the first time I saw this was on some high-end racing engines. So this is something that a lot of the high-end racing engines have gotten away from the crank snout and use a bolt-on type damper pulley. So I'm gonna go get the tools for it. I will zap it on real quick and then do the torque procedure. These are also torque to yield, so I'll need someone to help me here in a minute hold it. Actually, I don't want to go too tight because I want the initial torque to happen with the torque wrench. All right, so I'm gonna go back to my torque list. So this is, these are all the torques. I put them in all in one place from the either service manual or from ARP or whatever, or like the rods when we found, and then I put them all in one space. So main, crank pulley is 30 plus 120 degrees. So turn this on. We are going to do this differently than I have in the past. I'm going to use my chain wrench. So I want to tighten that way, so I want to pull up that way. So if you ever use one of these, don't put it on the serpentine belt. It doesn't fit there. So last time I did this, we didn't have the pilot bearing welded on the end of the crankshaft, and I was able to use flywheel bolts, but that's not possible now. So I'm going to hold the crank from turning with this tool, and then I'm going to double check my torque. 30, 120. All right, so everything's torqued to 30. Now I'm gonna torque it to 120 degrees, which is gonna be tricky because it's gonna wanna turn. So if the whole thing turns when I'm torquing the degrees, then the torque wrench won't read properly. So I have to be a little careful here. Okay, that's set to 120. Get this on there. Put this on, so I'm gonna start at 9 o'clock. So what's amazing about this torque wrench is you can actually go like 60 degrees and then ratchet it back up. It holds the 60 and then you can do the other 60. I mean, I had this other thing where it had a little like needle, and I was like, no, I gotta buy the expensive one because it's so much. Yeah, this thing's amazing. This thing's amazing. So I'll do whatever that is, and then I'll just keep going until it goes green. So that's 120 degrees. So now I'll do 12 o'clock, and then I'll finish on the 3 o'clock bolt. 600-ish? Yeah, they're 600-ish, I think, something like that. I did. I mean, look, if I didn't do this for a living and I just had an engine to rebuild, you know, I may consider doing something that takes a little longer. But if I'm doing this for a living and I'm trying to time is money, then the $600 is well worth it. Okay, so I've got all 4 of those torqued. I had to use the chain wrench. So it left a couple little marks here, which I'm fine with. But you'd never use the torque wrench on the serpentine stuff because you could damage the grooves. So put that away. Okay, so that's torqued on. And then in order to turn the crank on this engine, there's a special tool for that, which is this socket. I think they're like 50 or 60 bucks, and they fit into the 4 bolts. So that's the special tool for that. So that's how you turn the crank. And I'm gonna get so I'm looking for a 3/8 to, there we go. This is 1/2 inch drive, but I don't want a big old 1/2 inch drive ratchet, so I'm just gonna reduce it down to 3/8 so I can use a small 3/8 ratchet. And then I'm gonna put the crank pin at bottom dead center. You come up, I'll show you. Can you see it's sort of spinning down there? So we want to put that all the way at the bottom there. No problem. So when I install the piston and rod, like this rod is sort of jamming down in the hole. We don't want this to hit the crank pin. So you put that all the way at the bottom, and then you'll see, I'll slowly guide it in. So I'm going to make sure the arrow is going to the front and align this. This doesn't always go perfect, so hopefully it does. The idea is to get it rotated properly, and then you kind of have to commit, or else the ring will get stuck in between the tool and the bore. So push down and then, yeah, done. So what's happened is the ring's gone past this, stayed compressed and gone into the bore. If you too easy on it, you're like, I'm gonna be careful. Sometimes that's when you mess stuff up, because you give it that chance to expand, and then it hits the top of the bore, and then you can mess up your ring. So I'll slide that down with my hand. Feels okay. And then on the bottom, I'll show you guys. I'll flip it over so you can see. All right, so what I'm doing when I'm sliding it down is we don't want the rod to hit this bearing surface. So I'm just sort of holding it centered and then pushing the piston down and guiding it so it just sort of seats on there nicely. That's it. And I'll double check and make sure that like quadruple check that my tang is on the intake side, which it is. And then I should have a number 1 on this rod. which we do, and then I'll make sure that we got a number 1 on the cap, which we do. Align the dowels. Kind of push those together by hand a little bit. And then get our pre-lubed bolts. Get them started. And then we'll zap them on and I'll torque them. Let me get the right tool for that. So these are half-inch 12-point socket. So I'll get my half-inch 12-point socket. We'll use an extension. There's a different torque wrench that I like for these, which is a dial type wrench. Actually, I will not use the extension. So this is a half-inch drive torque wrench that has it's just a needle. And the reason I like these is because I don't have to set it to each one of the torques. I just see what I'm getting. And it's a half-inch drive, so I'm going to reduce that down to a 3/8 for no particular reason other than this is a set of sockets that I have, the 12 points. And then I'm going to, actually before I get to that, I'm just going to get those seated. No, because the torque is still the torque. If you have like a long extension, it may start twisting, so you may never get to the torque because you may be twisting the extension instead of getting there. But the torque is the torque. Yeah. Okay, so I'm going to go. I know the torque on this is 58, so I'm going to do 30, and then 30. Make sure everything seems okay, and then do 58, and then 58, and that's it. And then when I'm all done, I'll go double check the torques on everything, kind of in sequential order. So now that that's on, I'll again look, make sure everything's lined up, got the number 1s on the same side. Turn the engine, make sure everything seems okay, nothing's hitting. Sometimes on a fresh build with something you've never built before, and especially when you're using a big rod or even a stroked crank, you may have to clearance the block a little bit, and you'll do that in the like kind of the blueprinting stage because you'll have to wash everything after. But I don't know, it's just something to check again. Just make sure the thrust is here, feels right, and it spins well, and then we'll move on to number 2. So another thing, when you blueprint an engine, you measure what they call piston to deck height. So the piston goes all the way to the top dead center, and there's a certain measurement from the top of the flat part of the piston to the deck. That's called piston to deck height. And if you start decking blocks a lot, then that can get a little close, and your piston to valve can get closer, and your compression goes up. But we haven't messed with that, so we already know that's right. So number 2, again, I'm going to bring the crank shaft pin down to the bottom, and then grab our number 2 piston, and then I'll line up the rings, put it in the tool, square it up, pray, push. Oh, so it didn't go in because I've got the whole rod and piston cocked a little bit, and then the rod hit the crank counterweight. So I just didn't do a good job squaring it up. Just didn't do a good job again. This one's a little harder sometimes because the block's angled down. So that's what happens when you're not forceful enough. It's fine. You just bring it all the way through. make sure everything's good, and do it again. I think I'm... So I don't think I'm pushing square on the piston. Sometimes this happens. Yeah, no, I'll get it. I just got to figure out what I'm doing wrong. Yeah, so I'm not pushing square on the piston, so it's going down at an angle, and it's getting stuck. It's not hurting anything, it's just not happening. So.
Would mallet happening?
Yeah, you could. So one of these sides, it's the same reason I'm hitting the crank, is because I'm pushing. Left or right? Maybe. There. Yay. So when you do fiddle with it like that, you really want to look at the bore and make sure there's not like a vertical line, which means that you may have messed something up and then it's now scratching the board, but everything looks fine. So I'll guide that on and then we'll move on. And then I'll get better at this one as we do more of them. But again, this is only this, what is that, the 8th piston I've installed on one of these. So sometimes engines have their own little tricks. And also I don't assemble engines every day. So I'm sure there are commenters of guys that maybe do this for a living every day, and they're awesome at it. But I think the biggest thing is be careful. If there's a problem or something's like holding you up, really look and see why that may be happening before you start bringing the hammer out or something. Yep, let me torque these two and then I'll get some questions. No, I want this torque wrench. All right, and then we're gonna do 30, 30, everything feels fine. 58, 58. Okay, and then I'm gonna rotate it. And that's another thing that I've learned, like, if you're in the middle of some like procedure and someone's like, the phone rings or someone's asked you a question, try to finish the procedure and then do that next thing, because that's when it's easiest to forget or make a mistake, is when you're getting distracted. And try to have the same routine kind of each time. That way you don't leave out a step. So now we got 1 and 2 in. And the cylinder bores look nice and smooth, and it turns and doesn't make any weird noise, so I'm confident that that's installed properly. So, yeah, so we'll take a break, answer questions. All right.
So Luke Productions.
Luke Productions, okay.
Are you going to upgrade the camshafts, higher lift maybe?
So the question is, are we going to upgrade the camshafts? And the plan is yes. So initially, no. Initially, no. We're seeing what we can get out of the stock cams. We've got an exhaust camshaft reground that has a little bit higher lift and more duration. That one's a little bit more straightforward than the intake. The intake uses the intermediate rocker and the adjustable valve lift technology. That one's harder. We can't just regrind the factory cam. We'd have to go with either a full billet cam that has a similar base circle, or build a different intermediate rocker that has a different ratio. That's a bit of time in like development and also manufacturing. So that'll take some time to get there. Other engines, you could do like what they call a hard weld up, where they they put a bunch of weld material on the cam, and then they can regrind it. These you can't, because it's a hollow cam with a pressed on lobe. So we can't do a hard weld up on these cams. So the answer is yes, not initially, but yes on the exhaust. And then the plan is to show that in the next video. So this engine here that we're assembling this week is going together with stock cams, but we've got a modified cam on the sidelines.
British Trains hub. What type of installation lubricant are you using?
So British Trains hub, what kind of installation lube we're using? So I'm using the Lucas high performance assembly lube on all of the bearings. I'm using just standard engine oil, non-synthetic. I think it's like a 520 or like a 1030 on all of the stuff, on all of the factory bolts that require engine oil. And the rod bolts are using the special Corilla lube. The ARP head studs are using their special lube, and the rings I'm using just a little bit of engine oil. But sometimes we have this Total Seal like blue sort of lubricant, but we're not using that on this one. It's just wedged. It won't even come through right here. Pardon me?
Is there still oil on the ring compressor?
Yeah, because all the rings have oil, so it's a good idea. I'll just add some. All right. What's up, man? All right. Yeah, cruising. All right, so again, make sure we're on number 4, align everything, then I'll torque it down, we'll keep moving. Zip it in. So all of these rod bearings have been checked for size. So what we do when we do that is we measure all of their crank pins, and I'll write that down on a blueprint sheet, and we'll actually bolt the rods together with no bearing, we'll put the bearing in the rod, all clean with no oil, and then we bolt it all together and torque it, and we'll measure the inside diameter, and the difference between the diameter of the pin and the inner diameter of the bearing bolted together in the rod is the oil clearance. Another way to do it is with Plastigauge, which also works well, but you don't have the real fine tuning ability as using a dial mic. All right, now we're on number 5. right. Turn the pin to the bottom. Almost there. All right, number 5, cap. Done. All right, one last piston and rod. And it's always a good idea to, we get our torque wrenches calibrated. Like some of these are, this torque wrench is probably from 2003. So every couple of years we'll send it out, and there's a place near us in Long Beach that we send it them to, and they actually calibrate it. So I know that when you're building a lot of critical stuff like airplanes and such, you have to use calibrated tools. So there are places that can calibrate it, and what we'll do is I'll calibrate something like a dial torque wrench, and then I can calibrate our other torque wrenches. Okay,
Good
thanks.
job.
Yeah, thanks.
Oh, keep watching.
Okay, see you later. Ready. Then we can calibrate our other torque wrench to the known one by seeing if it clicks and then looking and see where the tattletale ends. Okay, anyways, okay. So number 6, which is our new piston. Got to turn it so the pin is all the way at the bottom. So that's why you don't want to rush and have a system. So I always look down into the board and make sure everything looks right, and it wasn't, but now it is. And then get the last one in. This one I may have let the ring come out, yeah. Just reset. All right. And then number six, the bolts. Okay, so now what I'll do is I'll say, okay, everything's torqued, but is it? So I'm gonna double check. So I'm gonna say 58, 58, and then I'll go to the next one over. I'm gonna double check. 58, 58, I'm gonna go to the next one, double check again. Number, what's this, 654, 58, 58. Yeah, this one's already up. 58, 58. So, I mean, the guy you want building your engine is usually a lot, maybe methodical and maybe a little, you know, OCD. That way they don't forget anything, or, you know, they have systems and, yeah. But not too much to where they can't get stuff done and they get stuck on things. All right, so crank rods and pistons are in. So we'll just spin it around a little bit, make sure everything looks and feels normal. So what I'm gonna feel for is like, does it feel consistent? Which it does. And then we'll do the same thing with it up. So back in the days, we'd have engines that maybe bent a rod or broke a rod or something. You pull the head off and you'll see one piston like lower than where it's supposed to be. So you can see 1 and 6 are paired. So what that means is when this is on the compression stroke, this one's on the exhaust stroke. So these are 180 degrees, or 360 degrees apart. 360 degrees apart. And then 2 and 5 are 360 apart, and 3 and 4 are 360 degrees apart in the firing order. So we'll leave number 1 cylinder almost all the way up to top dead center. And so now rotating assembly is done. Let me see how much time we have to keep going on some of the timing chain stuff. How are we doing on time?
About 15 minutes.
Okay, so I'll put the timing chain stuff on. This engine is unique because the timing chain is actually on the transmission side. What makes that different is usually on the front. But I guess a lot of race engines, and it seems like a lot of the modern engines, are moving the timing chain to the rear. I don't know exactly why, but I do know that there's a little bit less, all these metal components, like the crankshaft and the cams and all that stuff, can twist up a little bit. So when you have the timing chain on the same side as the flywheel, instead of, okay, so when the crank wraps up, you can, the cam timing can actually change. And I believe it's more stable when it's on the rear of the crank. All right, let's see here. What do we want to do next? Give me a minute to clean up a little bit. Put that away. Actually, I'll clean up after. All right. I've got a hidden box. All right, so this is our oil pump chain, this is our timing chain, this is the oil pump bolt, this is the timing chain cover, this is the baffle for the oil pan. This we probably won't get to. Oil pump bolts, the actual oil pump, which is massive. This is a tool that I probably won't use. Timing cover bolts. When I first pulled apart this engine, it seemed like daunting. Like there's so many different parts I've never seen before, and so many different screws, and then, you know, kind of after doing it one time, now I can look at a bolt and know where it goes. It's, I guess it's one of those things where it's a little bit scary when you kind of first start the project, but after you do it, the confidence level rises because you know it can be done. So some of these bolts we actually didn't clean. We left the oil on it because I like to assemble stuff with a little bit of assembly lube. And the oil and everything was so fresh that we just left it. So that's all the stuff we're gonna do to now. Okay. The next step will be the crank baffle. Okay, so this piece bolts not only to all the main caps, but also the block itself. So it serves two purposes. It stabilizes all the main caps and ties it in, makes it one big rigid structure. And also it separates the oil in the pan from the spinning crankshaft. So this actually goes this way. Fits on just like that. And it's got all these bolts, so it's got a lot of hardware that holds it in. And again, this is something that you didn't really see. You only saw in race engines years ago that a lot of factory cars use nowadays. And we would continue to use. It's good stuff. All right, so next we will bolt those in. Those are an e-torque socket, which I have up here. Maybe, do you want to get a shot of the toolbox? It's kind of cool, all the tools. So we didn't bring a whole, like every tool, we kind of just brought, we brought up a lot of tools. So these are all the sockets. So 1/2" drive, 3/8 drive, 6-point. These are 3/8 drive 12-point. These are the e-torques sockets, and these are just normal torques. And then, you know, hex sockets and stuff like that, miscellaneous. Then I got a bunch of different ratchets hiding back here. So these are the sockets for the oil pan, and we'll use one of those. So same thing, I'm gonna just zap them in and then come back and torque them.
So if you've got 5 minutes,
Okay.
when we say 3, we'll wrap it up.
Okay, so we're just gonna get through this this baffle here, and then tomorrow we'll start on the oil pump, the timing chain, and then get the cylinder head on. And I don't recommend always using an impact to initially drive it in unless you have like a really good feel and have done it for a while. Okay, so torque on this, again on my chart. So this is the oil baffle plate. That's 11 pounds and then 45 degrees. So let's go do that. So we'll turn this on. All right, so $11.45. So I'm setting both of them right now. So 11 to 45, so then I can just knock it out. This one I'm not going to worry so much on the order. I'm going to come down the middle. 11, 11, 11. This is where these torque wrenches are better than the dial ones because you don't even have to look at it. You just listen and feel for it. Okay, then I'll switch over to angle, 45 degrees. This is where these torque wrenches are worth it. Done. Okay, so all these are torqued. The whole rotating assembly is done, and we're good to go until tomorrow. So, Jen, any more questions from the web? Okay. All right, so I guess thanks for watching. Thanks for, some of you guys were here the whole time. So any questions from you guys?
So you guys are going to utilize the variable cam. Are you guys going to run that at maximum lift all the time, or are you still going to run it?
So we're going to run the variable valve lift, just set at maximum, and the throttle body will do all of the throttle versus, I think factory, it uses that variable cam to do the throttle, so we're just going to max it out. And we made a little fixture that holds it at maximum. So I'll show that tomorrow when we put the head and the cams in. And then we will use the variable cam timing as well. So we're going to use both of those technologies. So I guess thanks everybody for watching. And thanks everybody on YouTube for watching. Tomorrow, we're going to start again on all the cylinder head stuff. And again, we're here at the 2019 Sema show. We're in the Toyota booth. We're live on YouTube. Right now we're finishing up, but for the next 2 days from 1 p.m. to 3:30 or 1:30 to 3:30. And please join in, leave a comment. We've been stopping and answering questions, and we'll see you later. Thanks for watching.